Welcome to class tonight and to the very last of the videos for 6th grade. I do hope that you're all having a great day and that you're doing well. Tonight we're going to be working on something that is the basis for an entire high school class and much of college as well. This, what we're learning tonight, is going to help us form a good foundation for much of what you will be doing later in high school. And I'm glad they introduced this topic because this is the big deal. Alright, so we've already learned a lot about right angles. But tonight, we're really going to pick them apart. Let's start with our vocabulary. So you see up here, a right angle, right there. And so there are two parts, technically there's three parts of a right angle. And each side has a specific name. So, we have the right angle here. The two rays, remember this is a ray, that's a ray. The two rays that touch the right angle are what we call legs. So once again, I look for the right angle's right there. The two rays directly touching the right angle are what we call legs. And I have leg A and leg B. Then, the ray, we'll use the term ray, the ray that connects those two legs is what we call, it's a big word, probably looks a little scary because it's ancient Greek, but the name is a hypotenuse. Okay, once again, hypotenuse. So our vocabulary terms that you need to remember are, first thing is, that's a right angle. I have a leg and another leg touching both sides of the right angle, and then the ray connecting the two legs is what we call the hypotenuse. Now, something is very special about right angles. Every single right angle you're ever going to see in your entire life is going to follow this formula right there. You say, wait, every single right triangle? Yes, every single right triangle you're ever going to see is going to follow that formula. So I can use this formula right here to find the lengths of my sides. It's actually very interesting. I use this formula. It's called the Pythagorean Theorem. The a squared plus b squared equals c squared. It's called the Pythagorean Theorem. I can use that formula to find the lengths of the sides in any right triangle. Just right triangles. Okay? Alright, enough talk. Let's go ahead and put this into action. So you see here I have a right triangle on the board. I have given you leg A and leg B, and we are looking for the hypotenuse. We do not know what the hypotenuse is, so let's work on figuring it out. So we're going to look like this. I'm simply going to put my numbers into my formulas. It's going to look like this. A squared is going to be 12 squared plus b squared, and b squared is going to be 9 squared, is going to equal c squared. Now we don't know what c squared is, so we're going to work on that. Now, to find what c squared is, we simply need to solve this formula right here. Alright, so 12 squared is going to be 144, plus 9 is, the 9 squared is going to be 81, equals c squared. So 144 plus 81 is going to be, and you'll notice, I'm going to pull up my calculator on purpose. Yes, I know, we've been talking towards the end of school about how I don't want you to become dependent on a calculator, but calculators are very helpful. So 144 plus 81 is going to equal 225 equals c squared. Now, that right now doesn't help me out a lot because I want to know exactly what c is. I don't want to know what c squared is. That's what I figured out. I figured out c squared is going to be 225. That's not what I care about though. I care about what is c. So now this should remind you what we talked about yesterday in class. The opposite of a square is a square root. So we're going to square root both sides. Remember, that's how I get my c by itself. So the square root of c squared is going to be c. Remember that, cancel each other out because it's the opposite, because they're opposites, they cancel each other out. So now I'm looking for 225 squared. Now here's once again where I pull up my calculator, and this actually I will be expecting you to do because this is very, very difficult. 225, square root of 225 is going to be 15. So in this case, c equals 15. Now the nice thing is, you can actually put that to the test. You can say 144 plus 81 is going to equal 225. Actually works out very, very nicely. So in this example, I figured out what the hypotenuse, remember that's the ray that connects the two legs, I figured out what the hypotenuse was using the Pythagorean Theorem. Big words, scary words. Just need to remember it's a squared plus b squared equals c squared. Alright, I'm going to take a little pause because I want to make sure let this sink in a little bit, because we're going to do one more. Now, so one more example is going to look, well, obviously it's a little bit different. Now you'll notice we're still using the exact same Pythagorean theorem. We're using the exact same. That thing is not changing. That thing is constant, and we're going to be using it tonight and tomorrow in class. So now I have a new triangle, a new right triangle, but I'm missing my leg. I know my hypotenuse, I know one of the legs, but I don't know the other leg. So that poses a little bit of a concern. Let's see if we can figure it out though. So I'm going to put all of my numbers into my Pythagorean theorem. So it's going to be a squared, we don't know a squared, plus b squared is going to be 13 squared, equals 14 squared. Now here's once again where I pull up my calculator, because while this is possible, this sure makes things a lot easier. So 13 times 13, remember that's not what I'm looking for. 13 times 13 equals, so it's going to be a squared plus 169 equals, once again, put my calculator, equals 196. Okay, so I have my a squared, I have my b squared, and I have my c squared. I have to figure out what I'm going to get a squared. Now, how can I get my a all by itself? Oh, I know. I can get rid of this right here. So we're going to do it like this. A squared plus 169 minus 169 is going to equal 196 minus 169. Pull my calculator. Okay, so 196 minus 169 equals 27. Okay, so a squared is going to equal 27. Now, we're back to almost the right answer, but we're left with one thing left to do. Remember, if we want to find a by itself, I just want a, I don't want a squared, I want a by itself, I need to square root. So I'm going to square root both sides. That's going to get rid of the squared. So the square root of a squared is simply going to be a. And I go back to my calculator. 27, square root of 27. Ooh, look at that. Big, scary number. Very big, scary number. But we're just going to focus on the first part. And so we're going to say the answer is 5.2. Not exact, but we're looking for pretty close. So in this triangle right here, the hypotenuse is 14, one leg is 13, the other leg is going to be 5.2. And so there I've used my Pythagorean theorem, the a squared plus b squared equals c squared. I've used that to solve, and I can either find the hypotenuse or the leg. All I'm doing is solving the equation. Well, ladies and gentlemen, that is the lesson. The key tonight is going to be able to remember the vocabulary. So these terms right here, leg, and hypotenuse, know those terms. And then obviously you'll need to know the Pythagorean theorem. a squared plus b squared equals c squared. You'll need to know that as well. Your homework tonight is going to be page 624, 1 through 12 even. Once again, 624, 1 through 12 even. Have a great night. Thank you for your attention, and I do hope you enjoyed the videos all year long. Have a great night.